right triangle is lying on its side, and let's call the points here R, S, and T, and we'll label this side as 13 and this side over here is 5. If we put our right angle right here, that means that 13 is the hypotenuse because it's across from the right angle, and that these other two sides are our legs. So we have a leg here and a leg here. Now the Pythagorean theorem says that the length of one leg, 5 squared, plus the other leg, we don't know what it is yet, will always equal the hypotenuse squared. So that means that 25 plus b squared equals 169. Now 25, I got that from 5 squared, and 169, that's from 13 squared. So if I want to know what b squared is, I'm saying b squared plus 25 is 169. So that means that b squared equals 169 minus 25. 169 minus 25, well, that's 144. So b squared is 144, and b would be the square root of that, which is 12. So in this case, b, this side right here, is 12. Stepping back, the reason when I had this step, I said 25 plus b squared equals 169, and therefore b squared equals 169 minus 25. That goes back to logic, like in this problem. If 5 plus blank equals 6, well, that means b is 1 because 5 plus 1 is 6. But how would you know that? Well, we're using addition here, so b plus 5 is 6. That means that 6 minus 5 would equal b, which is 1. So it's undoing. You use the inverse operation. If 5 plus b is 6, well then 6 minus 5 will give you b, and 6 minus b will give you 5. So if b is 1, 6 minus 1 is 5, and 6 minus 5 is 1. So we can always get back, and that's what we have right here, except it looks a little bit more complicated. Instead of 5, we have 25, plus b, instead of b, we have b squared, and that equals a bigger number, 169, but the principle is still the same. If 25 plus b squared equals 169, then 169 minus 25 will give us b squared. And we said b squared is 144. We want to know what b is. It's the square root of that, so b is the square root of 144, which is 12.